So this is the small. This is the small intestine, and it's the wall of the small intestine. We have the outer layer here, which is longitudinal muscle, which is going to be peristalsis activity. We have the inner layer of circular muscle, which is going to be doing the segmentation and mixing. And so we also have the autonomic innervation. All of these areas going to be innervated preganglionically by the preganglionic fibers coming through the vagus. Cranial nerve number 10. Cranial nerve number 10 is going to come down to here to the Meissner's plexus, where the cell bodies of the postganglionic fiber exist, and they're going to innervate there. And so the Meissner's plexus will innervate the inner circular muscle for segmentation, and then there's going to be the vagus coming down to the Auerbach's plexus, which will innervate this outer longitudinal muscle for peristalsis. And then right here, as we move inward from the what is this? The muscularis externa to the submucosa. The submucosa is going to have special things in it that will include. Good. The Peyer's patch here, and the outer aspect, the distal aspect of the small intestine called ileum. And then notice right here, we have the muscularis mucosa. I'll use the pen. Muscularis mucosa. Okay, notice that this coloring is wrong. This should have, for a germinal center, it should be light colored on the inside and dark colored on the outside. And then here we have the villi, okay? And between the villi is the crypts of Lieberkühn. Way down here we have various kinds of digestive enzymes and hormonal releases, hormones such as somatostatin, and there's going to be some local serotonin, stuff like that. All of these little goblet cells here are going to release mucus. Here inside the villus is going to be capillaries as well as lacteals. So the end vessels of those. Then notice that over on this side we're going to be having the Brunner's glands, which are going to secrete mucus into the intestines. So, and notice that on this very underside here, we actually have, this is simple squamous epithelium, which means that is going to be the visceral peritoneum. Okay, so there's that.
So stop it or just keep going? Keep going.
And then we have this model. So we have the kidney, and we have the cortex of the kidney out here, and the medulla of the kidney. We have a separation where the arcuate artery is going to be the landmark separating. You can see that out here we have where all the glomeruli or renal corpuscles are. Some of the Henle's loops are going to be hanging down into the medullary region. All of this parallel line structure here is mostly going to be the collecting ducts. Okay, and then we move over here. Here's the pyramid with everything parallel. Here's the arcuate artery and vein that separates cortex from medulla. Okay, and so then we have the afferent arteriole and the efferent arteriole, which means the glomerulus is under high pressure. We have the nephron here, beginning with the Bowman's capsule, proximal convoluted tubule, distal. The descending loop of Henle, ascending loop of Henle, distal convoluted tubule. But it's going to be the ascending loop of Henle, which is going to form out here this aspect of the juxtaglomerular apparatus. We're going to end up with the collecting duct down here, and the filtrate will become urine ultimately at the end of all of this, and it will enter the minor calyx. Over here we have the renal corpuscle, and we have the juxtaglomerular apparatus, and this is the afferent arteriole. We have the granular cells here, or of the afferent arteriole, which is going to be able to release renin. And then over here we have the ascending loop of Henle, which is going to have the macula densa cells. The macula densa cells can sense low levels of sodium when the diet lacks sodium, or when the blood pressure is so low that everything gets absorbed and so very little sodium comes through. So it's either going to sense low sodium or it's going to sense low blood pressure. It will talk to the juxtaglomerular cells over here in ATP and tell them that they need to release renin in order to increase the blood pressure. Okay, so are we done? No, we have still this one. How are we doing? Okay, so over here we have the trachea, and so this is going to be where the vocal ligaments are, right here. The vocal ligaments will have their one attachment site anteriorly at the laryngeal prominence on the thyroid cartilage. Back here we have the arytenoid cartilage is the posterior attachment site, and then if this was hooked up together correctly, we would have a tendon here which would be able to actually open the glottis. So the glottis is formed as the opening between the vocal folds. Right, and so this muscle that's innervated by the vagus nerve recurrent branch is going to be called the posterior cricoarytenoid, and it is the only muscle that can open the glottis. And so you need to have that. We have our little buddy here who is the thyroid gland. So we have the thyroid cartilage, we have the cricoid cartilage, and then all of these are unnamed cartilages going around that way. This is the hyoid up here. Here's the epiglottis, and that's it. Oh, we still have to do the ear. Sorry about that. The ear. Okay, so here's the ear, just the way you like it, the external canal, and this is all temporal bone. And so we can take the temporal bone apart, and we can see that the external external meatus or auditory meatus is also the ear canal. Here's the internal auditory meatus or acoustic meatus, which has cranial nerves 7 and 8 going into it. And so an aspect of number 8 is going to be cochlear, vestibular cochlear, right? And so the other aspect of number 8 is going to be vestibular, going over here to the vestibule. The vestibule is going to be where we have sensation for balance. So we're going to have both dynamic and static equilibrium being sensed there. Here's where we sense sound, is in the cochlea. Here is the oval window with the stapes or stirrup stuck in it. And then we have the anvil or incus. We have the malleus or hammer. The malleus is embedded in the tympanic membrane. The tympanic membrane is right here, and so we're going to have the pressures of sound coming in this way. This is the middle ear, and so we have the eustachian tube coming down this way, going to the nasal cavity. Okay, that's about it for that.
And we're out.
Thank you.